Well, thank you all for being on this panel. I feel like this is a rare opportunity because you guys are literally, you three, are laying the foundations of open source AI infrastructure. So for people who don't know, Don is one of the founding team members of Kubernetes. Joe's the product lead for PyTorch. Simon leads vLLM. So we're super lucky to have you here. Here, come sit down. Super lucky to have you, to hear your insights about AI infrastructure and how that's evolving and where you see that headed. So would love to start, with each of you just sharing what you've seen personally with how AI infrastructure is evolving. And maybe Joe, you can start with PyTorch. PyTorch has helped really democratize deep learning. Like, what problems were you initially trying to solve with PyTorch? How has that changed?
Shouldn't it be like us four? I mean, you didn't even include yourself in that. I mean, seriously, we kind of have the stack here, kind of up on stage. This is kind of fun. Yeah, so good to see everyone. Yeah, I think, so the interesting thing about PyTorch is like the goal from the beginning was actually like very narrowly focused on research. Like we focused actually on training efficiency, training speed, like time to experiment, ablations. Like those were kind of like the things that we focused on because it's what mattered to researchers, right? They wanted to ideate, they wanted to explore the space. And so for them, like inference performance, no offense at the time, but like at the time, inference really didn't matter. It was all about training. And
does it matter today, do you think?
I'd say so. Like I think times have changed. I mean, I've been in the space now a long time, and like training was cool and it was important, and it's still obviously important. But like now, it's like inference, like this is the new blood, right? I mean, vLLM is everywhere. It's dominant. It's important for RL. It's important for production. It's important for a bunch of different areas.
It's okay.
But yeah, for us, it was all about like how do you actually like make researchers efficient. And that was honestly the problem we were trying to solve. And like it's all about Python. It's all about like speed of experiments. So yeah, we focused.
Yeah. And by the way, Simon, vLLM is not the first inference engine you've worked on, right? You've been working on inference research for a long time. Can you share a little bit about that?
Oh yeah. So it was quite great. Like since we received the rate.
Can you hold the mic a little closer? You might have to just do it manually. Yeah.
The first one to see the rate serve that.
Oh, mic down. Great.
And that was one of the early projects that we built here at Anyscale. I was previously working at Anyscale as one of the founding engineers was Robert here, and as well as was a great team here. And at that point, we're working on recommendation system, we're working on regression model, time series prediction, and simple classifiers running on CPUs. And just at that point at 2020, 2019, and then LLM was just the initial ideas. And over the time of 2022 and 23, we start seeing the growth of large language model as an architecture growing from BERT, which was bidirectional at the time, and to decoder only as GPT-2 has shown. And pretty much over time, we're pretty seeing going from CPU-only inference with diversity of classifier and regressor to nowadays large language model powering almost all of the AI stack.
So what changed? Why is inference so central and vLLM so central to AI today?
So what vLLM does is inference engine takes the large language model that's open source or proprietary and run it on data center hardware. You do need the flexibility and performance to run those models efficiently at a lower cost. And vLLM sit at the center, where we bring the most amount of large language model architecture in pure open source, run on the most efficient data center hardwares. You actually do need all of that capability to make sure that we're furthering lowering the cost of inference while you are really using the capability and leveraging it for the new model and product you're building.
Yeah. And Don, can you share a little bit about Kubernetes? Like, what use cases? It started before AI was really taking off. So what use cases were you building it for?
Good question. When we first started off the Kubernetes, it is originally designed for the stateless application, right? So those like workload is the informal, and it's really perfect match for the web services and also simple APIs. But however, over the last decade of the evolvement, actually we are basically expansion to support the full spectrum of the enterprise workload, from of the stateful workload, and while of the concepts of the stateful site and also CSI, and two of the batch and workloads and job workloads, while of the Kubernetes jobs and the queue mechanisms. Those it is the essentially critical for those AI training and inference jobs. Yeah.
So what has that process been like of evolving Kubernetes to really support AI well? What have been the hardest parts?
Hardest part, it is a lot of the concept and shifts, right? So in my mind, there's the three major of the shifts. And one, it is the data locality. And so we introduce a lot of the features, for example, like of the node typology label of the features, which it is enable about the enable like a framework like the Ray and also other of the framework on top of the Kubernetes. So you can make this intelligent and typology while scheduling and also the placement decision, and which is allow of the high speed of the GPU to GPU communication. This is one of the major shift. And another major shift, it is we are moved from the services centric of the wheel to the job based of the centric wheel. So we introduce the high level of the concept of the job and also evolve of the Gantt scheduling. So then which it is prevent of the waste of the computer resource, and all those kind of the job have to, like the worker have to start at the simultaneous and or maybe just do nothing. So a lot of for those kind of shift, actually it is really critical for us. Also have the performance and reliability and high requirement to Kubernetes. We are working on those kind of things.
Yeah, jobs are really fundamental to AI, right? And like Slurm started more from that world, whereas Kubernetes started more from services. Of course, now you can also run Slurm on top of Kubernetes. Yeah. So let's talk a little bit about where you guys see things headed. Joe, maybe you can share, since you helped create the PyTorch Foundation, like,
Sure.
Why'd you do that?
Why do we do that? Why do we do that? So I think we started the PyTorch Foundation, I guess, now just under 3 years ago. I think that like the conversation actually started probably actually more like 7 years ago, when we really kind of merged Cafe 2 and PyTorch and brought the teams together, and we created this vision. And I think like ultimately we treated the project as if it was a foundation from the beginning. We wanted as many folks to come together. We wanted to give agency to the community, to code ownership. From the early days, we had the project modularized so that different folks can own different parts of it. And that was really important to us, because I think we wanted it to be this durable thing. We didn't want it to be like this cool project, you use it for a couple years, then something replaces it. Like, we actually wanted to build it for longevity and scale, like from the beginning. By the way, my secret agenda is to convince Dawn to bring Kubernetes into the PyTorch Foundation. We'll see after this panel if I succeed. But ultimately, like, we do want to bring in the best of breed, like with PyTorch and vLLM and all these things that people depend on, and start to scale up. I mean, Ray is a big part of that, and this stack is, like, these are communities I think that are awesome. Like, I think the Kubernetes, on CNCF, and I think vLLM is like just rabid, and Ray as well. And when you bring these communities together and they start thinking together and working together and designing together, like, I think a lot of these projects are designed a little bit in isolation, and we kind of, as a community and through partnerships, we make them work together. There's a lot of blood, sweat, and like pull requests late at night that get these projects to work together and collaborate. But I think like bringing them under some kind of umbrella together and thinking about a vision together, I think is really what I envisioned, and it's starting to really come true. I think like between Ray and vLLM, it's awesome. We want this to be a small set of projects that really are tightly coupled, and build the future of kind of how AI is developed and built and deployed, and kind of, for not for like just the next year, but really for the next 5, 10, 20 years.
I'm actually curious for all of you, where you see opportunities for collaboration across projects. Like, what can we achieve, by deeply integrating different projects that's hard to do without doing that? Simon or anyone?
Sure.
Yeah.
So one thing that vLLM is recently pushing for, where we can see this really cross-stack optimization happening, is that as models are getting bigger and bigger, as you become a lot more capable, you need a large-scale cluster to run inference. So it is no longer the case where you can run the model on a single GPU, not even the case to run the model on a single node, which typically have 8 GPUs. Rather, you actually need to scale it to potentially hundreds of GPUs. At this case, it becomes kind of somewhere between single node inference to training, where you actually need to specialize the serving system, both entirely across the stack from where the API sits, how is the model architected, as well as how does PyTorch and Ray handling both memory management, compute kernels, and down to the Kubernetes side of where do you place each pod and then making sure they all get scheduled and scale elastically nicely. And this is pretty much a cross-stack effort across the entire PyTorch, Ray, Kubernetes, and vLLM stack.
Yeah. Don, can you say anything about how Ray and Kubernetes have been working together, or future work we can do together?
Robert, before this panel discussion, and Robert gave all of us some something fun to talk. Here is the fun story. Before I started looking into how to support of the Ray, like of the framework, and there's already have some effort on the open source called Kubernetes, right? So last year, I did the same resubmit. I really want to support of the Ray, like evolve Kubernetes and support the Ray natively. So I tried to get myself, to introduce myself to Ray teams, any scale teams last year, but I just failed. So then I get myself a free pass and get to the resubmit last year. And there's the one talk about the Kubernetes. Then after, and one of the speaker, it is from the any scale engineer. Then I just hijack a conversation after that because they ask a question, complain about the Kubernetes friction. So then I just give the answer. And I said, how about I provide those solutions? After that meeting, and I stopped at the speaker, and I said, okay, can you introduce me to your leadership and introduce me to your team and the community? He did. And then we start off this kind of partnership on the open source, and also earlier you heard of the Google relationship, right, partnership. So what I try to say that is I really want to evolve Kubernetes. It is to meet the help support of the Ray, especially of the elasticity and the resilience. Right? Ray is different from the other framework, and the elasticity and support. So to support the true elasticities, we have a lot of the ongoing projects. One of the projects is like in-place pod resizing. We recently have the simple of the benchmark, and we found of the in-place pod resizing, leverage Ray workload, and we have like the 30% of the performance boost, and to make those work and finish, right, so completion time. So those kind of things, and we also have like the ongoing of the resize node, which all together and allow of the Ray can be like allow the infrastructure can scale faster ever than the before, right? So the before, and also allow the Ray, and also can take response without any of the disruption, and for restart. And another thing,
if I can just add on to that,
yeah.
actually, to do a good job with in-place pod resizing, you want to have a good understanding of what's happening inside the container, right?
Yes.
And that's the kind of workload awareness that Ray can provide.
Totally. We try to make of our Kubernetes, it is the framework a while and the Ray a while, and the customer metrics, and give the signal to underneath infrastructure. So you could spin up the cluster, expanded of cluster much faster, and also you can take action, right? So to detect of the failure, hardware failure, software failure, and also replace of those kind of things. That's kind of the infrastructure we try to build, also for the resilience, and to provide of the scale, reliable of the foundation, to power like the high level of the distributed framework like the Ray, and also high performance inference stack like the vLLM, and also together with Meta's Monarch, all those kind of things we build of the complete complementary of the open source AI stack. That's kind of the Kubernetes as our infrastructure. I always call myself, and also of the people work on the infrastructure, kingmaker. So we are basically just allow you focus on the high-level innovation, and we take care of the rest of the infrastructure.
And
yeah.
Joe and Simon, love to also hear from you, just maybe to wrap up. What's left to do? Is open source AI infrastructure kind of done?
I mean, we're definitely not done. I mean, I think like to Simon's point earlier, I think scale continues to be a theme. I mean, I think when I was first training models 10 years ago in CNNs, like we had a paradigm of training a model and you could do it on a single GPU, and that's where AlexNet, for example, like single GPU, and then we started scaling up to, you know, single machine, and we did distributed, and it was pretty messy, and it wasn't very easy for anyone like besides probably like the researchers or experts to do that. We're now getting to the point where we've kind of like democratized scale to some extent. I think like that part of that is Ray, part of that is Kubernetes, part of that is PyTorch, and like, but we also have like on the inference side, we need to distribute. Like not everyone was thinking distributed inference like a year or two ago. So I think like we still have a lot of work to do in my opinion actually to bring these things together. Numerical stability across the different components is still a thing. You know, how do we actually get more determinism in the system? And that comes with like testing and building these projects more together. And that's, I think, why, again, we build these communities, and that's why we bring these experts together and these projects get co-designed and co-developed together. So that to me is like, I think the next stage of where this goes.
Yeah, you just briefly mentioned determinism, but that one word is hiding a lot of work.
It is, it's a huge amount of work in so many parts of the stack.
Yeah, and then just to add on top of that, high throughput and scale is one part. Models are getting innovated architecture-wise every single day, as was new chip is being taped out and experimented. That we're both experiencing in the future of inference is going to be you can go through the highest throughput ever, but also have lowest latency as well. So that you have one engine, one stack, we can go with millions of request tokens per second, but also where when you're using it, it feels instant, snappy, and all the time, always on.
Yeah. Hey, this has been a fantastic discussion. You know, thank you guys for sharing your insights. I'm always excited to see how much innovation is happening at the infrastructure level. So thanks for your insights, and also thank you, more importantly, for all the great open source work you all are doing. Please join me in thanking Don, Joe, and Simon.